Hello viewers, in today's video we'll be discussing about scientific notation. So scientific notation is like a shorthand in expressing two large or two small numbers, and it will always goes with this format: a times 10 raised to b, where a is the coefficient, 10 is the base, and b is the exponent. So the exponent can either be positive or negative. And our base, the 10, will always be constant. Whereas your a, this one, your coefficient, is a number which is greater than or equal to 1 but less than 10. Again, your coefficient should be greater than or equal to 1 but less than 10. Let us identify the coefficient, base, and exponent of these scientific notations here. The first, we have 3 times 10 raised to 8. The coefficient here is 3. The base is 10. And the exponent is positive 8. Now, the second scientific notation here, the coefficient is 1.7. Okay? The base is 10. So, notice that the base will always be 10. And the exponent here is negative 4. Let us convert the following numbers to scientific notation. But before doing so, let us be reminded that the rule for the coefficient a should be a number that is greater than or equal to 1 but less than 10. Now looking at the first example, we have 2 million here. The coefficient will be 2 because 2 conforms to the criteria or the rule that a, the coefficient, should be a number greater than or equal to 1 but less than 10. Now, how will we convert this into scientific notation? Now, we will be moving places from a point. If you have decimal numbers just like this 2 here, the decimal point is shown. It's visible. It's obvious. Now, for whole numbers, the point is always after the last digit. So for 2 million, the point is here. So we will be moving places from this point going to the left. Let's start moving the point here. So we will start here. 1, 2, 3, 4, 5, 6. So we will stop here. So your coefficient now would be 2 or 2.0 if you like. Then times 10, the base 10 is always constant. Then your exponent will be how many places have you moved. This is 1, 2, 3, 4, 5, 6. So you will write here 6. And since you move the point going left, it will be a positive exponent. So the coefficient now is 2. And the exponent is positive 6. So this is the scientific notation for 2 million. Number 2 example, we have 610,000. So this is a whole number, just like number 1. So the point will be after the last digit, so it's here. And our coefficient will be 6.1. So we will be moving places until it stops here. Okay? So we cannot get 610 nor 61 as the coefficient because it will violate the rule. Remember that the coefficient should be a number greater than or equal to 1 but less than 10. So now we can move this point going left. 1. As you move, you count. So we have 1, 2, 3, 4, 5. So right now, the coefficient, it's 6.1 times 10 raised to, how many places have you moved? 1, 2, 3, 4, 5. 5. And since this is a whole number and you have moved the point going left, this will be positive. So your answer for scientific notation is 6.1 times 10 raised to the power of 5. Let's proceed to example number 3. This time we have a decimal number. The last 2 examples are decimal numbers, while the first 2 are whole numbers. So obviously the point is seen here, this point here, and we will be moving this point going to the right until we reach the expected coefficient. So again, remember the rule for the coefficient. Now we can start moving 1, okay, 2, 3, 4, 5. We will stop here. What do you think? Look at again this rule here for coefficient. It should be a number greater than or equal to 1 but less than 10. If we stop here, it will be 0.5 and it is less than 1. So we need to move 1 more. Okay? So our coefficient will be 5. So write 5 times 10 raised to the power of, again, count how many places have you moved. 1, 2, 3, 4, 5, 6. So it's 6. And since you move the point going to the right, it will be a negative exponent. So your coefficient is 5, while the exponent is negative 6. Because you have moved the point going to the right and you have a decimal number. So the final scientific notation is 5 times 10 raised to the power of negative 6. Last example, here we have another decimal number, just like in number 3. We will be moving this point here, going to the right. So now we can make the movement 1, 2, 3, 4. 0.9 is less than 1, so we still need to make one move. 9.73 is greater than 1 but less than 10. Okay, so we can stop here. We cannot proceed one more because if you proceed, if you make another move, this will become 97.3 and it will violate the rule for the coefficient because it should not be greater than 10. It should be less than 10. So now we can write 9.73, the coefficient, times 10 raised to how many places? 1, 2, 3, 4, 5. 5. And again, since this is a decimal number and you move from this point to the right, then we have a negative exponent. So this is negative 5. We'll just write it again, negative 5. So your scientific notation is 9.73 times 10 raised to negative 5.